Hello?
We're back. So now we're going to talk about the EIC Pathfinder topic. So please, let's not forget that the Pathfinder is about game-changing breakthrough innovations. And the topics we'll discuss will be, first we'll start with the Pathfinder, and my colleague Darina Botsova from the Pathfinder unit will be here to answer questions. You are welcome to ask your questions in English, Bulgarian, or French. So unfortunately, we don't speak the other languages of the European Union, but you would have a budget overview. Then I would give a very general background, a deep dive in the topic, present the identified gaps, the topic for in-space solar energy harvesting for innovative space applications, and also present the portfolio considerations which will be used from the challenge guide and the expected outcomes and impacts. So this year's topic is about in-space solar energy harvesting for innovative space applications. As I mentioned earlier, it's TRL 1 to TRL 4. These are for projects for game-changing breakthrough innovation, where it's researchers, scientists, SME starters, and mid-caps or bigger companies can partner and create consortiums. So what is the Pathfinder about? It is developing a scientific basis to underpin breakthrough technologies. It is to support the early stages of scientific innovations and deep tech R&D. It is when you have a completely ambitious and radically new technology which you want to go through. And later on, we have, for example, projects in our Pathfinder, Space Pathfinder portfolio, like ET Path for using tethers for removing space debris, or we have the MESS projects for high temperature superconductors. So they have quite a few interesting projects. EIC Pathfinder is organized by open and by challenge. So as you see, if you have any new cutting edge direction and ideas, please do go ahead and apply for Pathfinder. It is open, so any project in any field. I do encourage you here also in the open, if you have low TRL ideas, not only for the upstream, but also for the downstream, navigation, SATCOM, Earth observer, feel free to apply. And the challenge will be linked to the space challenges, which I will present a little bit later. So this is important information because when you apply for under the space challenge, under the EIC Pathfinder, you can also have a consortium of two entities, legal entities, which are established in member states or associated countries. So you're not obliged to have minimum three consortiums. So you can have two entities independent. You can have more. Actually, the projects which are most successful I have witnessed are with universities, research institutes, also often having the end customer as part of the consortium, but always with an SME and startup as being part. And it's 100%, the eligible costs 100% funded up to 4 million. And of course, it's also appropriate if larger amounts are justified. So Pathfinder calls. The open one is for 3 million. So and the deadline is the 7th of March. And the challenge one is for 4 million, and the deadline is 18th of October. I know it's maybe too early, but it gives you the opportunity to actually find partners and already start creating consortiums. The first one is a 17-page proposal. The second one is a 25-page proposal. So next slide, I would actually do a deep dive in the topic. So the topic I will talk about is in-space solar energy harvesting. And as you know, space-based solar power has been a topic already being discussed from 1968. There are many countries looking at it. JAXA, Japan, the Japanese Space Agency is looking at developing a commercial solar power station of 1 gigawatt by 2023. Also, Europe has just recently launched the ESA Solaris program, which is going to look at various feasibility studies and look at technology developments for future space-based solar power from space to Earth. Also, US. The US, we have actually witnessed the Northern Grumman demo, and there is the alpha concept from John Mankes, which has been developed, and there is a whole book about it. And then in China, China is aiming at launching a demo around 2030, at also having a commercial space station in 2050. But in Europe and beyond Europe, one of the other countries which is very active is the UK. And the UK's government has put some initial funding for feasibility studies too. So there is a very, very strong interest. However, I would like to look at solar in space solar energy harvesting. So using solar energy from collecting it and using it from one spacecraft to another. And using small sats, for example, or using solar energy for powering small sats or CubeSats as a means of propulsion. Or there are also trends of looking at various cost-benefit studies. There are also ideas for having a lunar power station in GEO, or using space solar power for assembling structures. So there are a lot of new trends and new developments. However, I personally think that in-space solar harvesting is a topic which is very much important. Here's just another summary, and most of the people who are involved in in-space solar power research know very well this type of various models. Here you can see a concentrator concept which utilizes scale mirrors to concentrate the sunlight in the solar generator. And these mirrors could be also assembled in space, so actually pushing the in-orbit assembly activities. So the various models, various concepts, and various ideas. However, I personally believe that and you know very well, the European Union is looking at this also, but there is an urgent need for clean and renewable energy. And in space, the solar energy is not obstructed by Earth's atmosphere, so we can actually use it and power and convert it and transmit it to other spacecraft. And it's a non-polluting energy source. In addition, in-space solar harvesting and wireless power transmission in space gives shorter distances. So you actually do not need to be, it's much more nearby. In addition, innovative in-orbit devices will emerge for solar energy collection. We will be able to learn how to use this solar energy with many applications, not only in space, but in Earth. And it would encourage the in-space mobility, help with space debris removal, but grow the in-orbit satellite servicing, end of active debris removal, and end of life activities. As you're aware, a huge percent of the satellite failures is also linked to power failures. And due to that, we would need innovative green propulsion solutions. But once, which will give us the opportunity to have an increased payload, to fly bigger experiments and not have the constant trade-off with the propellant, and result in potential fuel cost savings. So definitely in Europe today, we do have the urgent need for strategic autonomy for renewable energy resources, but also in space, not only in ground. Plus, with the rising prices of propellants, it's very important to have this type of capabilities. So what are the ideas? The idea is to develop a concept or technologies that you need to collect, convert, and transmit solar energy. And you can use the solar energy for innovative propulsion technologies. So scalable solutions, so different type of rectenas or PVs or and so on. Ones which not only capture the energy, but they could be low cost, low weight, and sufficient. Then converted from direct current to RF of this harvested energy in a form which is appropriate for long distance, but in empty space. So it's very important to remember that that is in-space solar energy. So please keep this in mind. It's about in-space energy harvesting. Efficient wireless transmission for in-space mobility also, and looking, as I mentioned earlier, for increased payload capability and potential fuel cost savings. And what are the portfolio considerations? The portfolio considerations when actually selecting, once the proposals are selected, there will be, the portfolios will be, the projects will be grouped. There will be two main categories: collection, conversion, and transmission of in-space solar power, which includes onboard spacecraft deployable panels, PVs, new types of transmitting antennas, and advanced solar arrays, conversion, transmission. And then we have the second category, which is in-space green propulsion, where we look at solar electric propulsion, for example, or use of solar sails for in-space mobility. Now, the enabling outcomes, and later on I'll deep dive into these functions, and the enabling outcomes will be interoperability, lightweight, but also increased end-to-end efficiency conversion, high efficiency from DC to RF, RF to DC, and light to DC. Wireless power transmission, it could be laser or microwave, and in-space propulsion system. So these are the first category. The first category is collection, conversion, and transmission. And down on the left hand, you see the list of the different types of areas I'm looking at. Important photovoltaic conversion with high efficiency, low mass, low cost. To be able also thin film, solar cells, onboard batteries, transparent antennas. All modular solar concentrators are very welcome. And then the next step is linked to the conversion, high efficiency conversion, rectenas. And of course, wireless power transmission, looking at the microwave aspects and the optical with the laser. So it is but wireless power transmission in space. So this is very important aspect which I want to make clear. Examples, there are the functions, innovative approaches. So I'll be looking at approaches, methods, and technologies for increased end-to-end efficiency, for collection, conversion, and storage in wireless power transmission, scalable solution, antennas, rectenas, solar concentrators, and innovative harvesting devices, because or grids, or looking at different concepts for retransmission stations also, which will not only amplify, but also redirect the beam, which is one of also the shortcomings, is the microwave beam, and so on. So the common element, expected outcomes, efficiency, interoperability, and lightweight. And of course, just my reminder, proposal should incorporate consideration for sustainable space debris management. Some examples. Here on the right, you see a transparent antenna with increased optical transmission. What is solar power, solar-based power satellite? So it's just a short description of what happens, but please keep in mind that this is in space. And here, JAXA has been also looking at inter-orbit energy transfer and planetary exploration mission concepts. So just imagine if we had these capabilities and if we had mastered them, we could have extended the lifetime, for example, of the Rosetta mission or other interplanetary ones. This is the first category. The second category is using solar energy for example, powering CubeSats or small sats. So the question is, can we power, for example, low Earth orbit satellites, small sat or CubeSats? In LEO here, there is just an idea up to 2,000 kilometers. Why? Because the distance is shorter in space. You have zero atmospheric influences, and there are limited safety concerns. So that's why it's very important to master this category in space. You can have also concepts where they look at a mesh of CubeSats to collect solar energy too. On the other side, you see wireless power transmission. Well, this is the astrobotic one for wireless power charging concept, which will be used for their lunar rovers, because after 2 weeks on the surface, the lunar rovers actually die. So if you're able to master wireless and have wireless power charging system, it would extend the lifetime of your rovers and your spacecraft. So this is the first category, and the second category is about in-space green propulsion. Why do we need it? I always ask myself, if we want to do in-space mobility, in-orbit satellite servicing, in-space assembly and manufacturing, active debris removal, and all these aspects, we need to be able to master the solar energy. And for this, we need to have in-space green propulsion. So on the right, you see a photo from NASA where an image, where looking at using, for example, water propulsion, water-based electrolysis spacecraft on a CubeSat. Plus, you know very well that the increased prices for xenon and krypton have created quite a few limitations. So what am I looking at? Solar electric propulsion, solar sails. I think solar sails of critical importance. Laser propulsion, using laser light to heat up propellant, or microwave propulsion, using microwave beams to heat up propellant. So it is important to see how we can use this energy, the solar energy, because this will help us to reduce the initial propellant we will need. It would help us, we will be able to build, let's say, in parallel, mastering the solar energy would help us to have reduced mass of the spacecraft and increase payload capacity and experiments capacity. So I think it's important to look at this aspect because it opens a new door, not only to space exploration, but to growing the new space economy in another parallel, having access to new energy sources. So here are the two components, which I have: collection, conversion, and transmission is the first category. The second one is in-space green propulsion, with various applications like in orbit satellite, ISAM, ADR, and end of life. And you're free to have a shared component or look for complementarities among the projects, either in each category or between category 1 and category 2. So, for example, you can use the energy, the solar energy, which has been collected and converted, and then power transmitted for in-space growing green propulsion. So looking at the shared component is important aspect. Or you can have also shared component in between one category two, for example. So what are the expected outcomes? The expected outcomes are the energy in space, energy harvesting and utilization of space, wireless power transition through power grids in space or use of energy beaming, eco-friendly, innovative solutions. So, for example, you can have projects where you can have the propulsion system can benefit from the solar energy. And the idea is actually to have, you will be able to grow and further mature the technologies for in-space robotic manufacturing and assembly of space-based solar power units, an important aspect which is considered. And finally, there will be a number of expected impacts, but you can read this further on in the work program. I believe that mastering in-space solar energy will give us the opportunity to have autonomous space tugs, innovative green solar antennas, or master new methods for in-space propulsion and have breakthrough technologies. But it would give us also autonomy and give potential fuel cost savings for end users. Satellite owners will be able to improve not only their in-space mobility, but by this extend the lifetime of their spacecraft, an aspect which is extremely important. And or gather energy which will help them decommission their old satellites and so on. So this is the expected outcomes from, also do not forget that all these innovative space applications will also contribute to ground-based ones in the domains of electronics and so on. So what is an important aspect is to remember is that in the portfolio consideration, you always have to add 10 person months. And these 10 person months could be for looking at barriers of strategic autonomy or technology non-dependence. You could use them for for communicating the outcomes of your activity, or, for example, proposing and developing new space, innovative space applications using in-space solar energy, or looking already at the early commercialization aspect, and or using them for accessing research labs, test facilities, or exporting or defining a product for exporting to non-EU markets and customers. And also, if you have certain technologies which are at higher level, tier 5 or 6, you can consider IoT